This is Miss Plant's video where I'm going to try and explain pressure and pressure difference in fluids for AQA GCSE Physics in 5 minutes. So, first thing to know is that a fluid is another word for describing a liquid or a gas. Anything that flows can be considered a fluid. And fluid pressure creates a force at the normal or at right angles to any surface. So this water in this beaker here is creating a force at right angles to the surface the whole way round, and the air is also creating a force at right angles to the surface. We can calculate the value of this pressure, and the pressure is equal to the force at the normal of a surface divided by the area of that surface. Pressure is force divided by area. P is F over A. Pressure is measured in pascals, PA, capital P, little a. Force is measured in newtons. Area is measured in meters squared. Pressure, you sometimes see it in newtons per meter squared, and if you forget pascals, newtons per meter squared is fine as a unit for pressure. If we have a column of water, the pressure calculation can be a bit more complicated. This equation you get given though, the pressure is equal to the height of the column times the density of the liquid times the gravitational field strength. The pressure in general in liquids is caused because of the weight of the air above you. So the lower down you go in the liquid, the more pressure there is. Pressure is H for height times rho for density. This is not a P, this is a rho, times G. Pressure, again, pascals or newtons per meter squared. Height in meters. Density in kilograms per meters cubed. And gravitational field strength, newtons per kilogram. Now, this diagram just explains what happens. The further down you go in the liquid, the greater the pressure is. And the classic experiment is to have 3 holes and see that at the bottom it shoots out with much more pressure than at the top because the pressure is greater at the bottom. Now, this equation can also explain this upthrust in water. When you hold something underwater, you get this upthrust force, and this occurs because the bottom surface of any object is going to have a greater pressure on it than the top surface of any object. The bottom surface has a greater pressure, greater force acting on it, and then because the force on the bottom is greater than the top, that means there is a resultant force acting on the object that acts upwards, and that is what creates upthrust. You need to understand the factors that affect floating and sinking. Floating and sinking is all about density. This duck floats because the density of the duck is less than the density of water. This brick sinks because the density of the brick is less than the density of the water. The thing, I guess, where you get tricky is it's the average density of the object. So something that is hollow, the average density is lower than something that is solid. Right. Then this bit here, the atmosphere. So the atmosphere on the Earth is very, very thin, relatively speaking, compared to the size of the Earth. Even this diagram isn't to scale. The atmosphere is pretty tiny. Near where we are, at sea level, pretty much, the atmosphere is much denser. The further up you go, the less dense the atmosphere becomes, the less air there is. So also as you go further up, there is less air above you, and that means there is less air pressure. Now, at sea level, the pressure is approximately 101,325 pascals, and that's because the air particles are hitting into you, so your face. The air particles are hitting into your face, causing this force, and it's actually considerable force when you think about it. Don't forget, pascals is newton per meter squared, but talking about your face, meter squared isn't that helpful. We can convert that into newtons per centimeter squared, which might be easier to understand, by dividing it by 10,000, because don't forget, even though 1 meter is 100 centimeters, 1 meter squared is 10,000 centimeters squared, and we get a value of 10.1 newtons per centimeter squared. That's about 1 kilogram acting on 1 centimeter squared of your face, so the pressure is not to be scoffed at. Obviously, if you were to climb to the top of Mount Everest, the air pressure there is significantly smaller. It's about 30,000 pascals on top of Mount Everest, and that is simply because there is less air, so there is less pressure. Now, questions. They might give you questions where they ask you to plug values into pressure as force over area. You have to memorize this equation and recall it. This equation, they might get you to use it, but they give you this equation. The units of pressure, they like to quiz you on. They might ask you to complete a diagram like this, or they might ask you to explain why upthrust creates or why things float.